Hello everyone, welcome to May 22 Zeam call. Today we will discuss DevNet for uh, scaling efforts, optimization efforts, as well as shadow runs and our plan for shadow runs, and a little bit about DevNet 5 readiness. So let's start with quick updates on DevNet 5 readiness from Kai, because then we'll focus rest of the call on DevNet for runs and shadow runs, shadow sims.
Uh, yes, this week I was working on the implementation of DevNet 5. Um, almost finished, but I found theme test failed. So check checked with May branch. It seems the theme test right now has some flaky failing. So Pasa Pasa submit new PR, so maybe I will look at it later.
So when do you think we'll be able to have the implementation for the Net 5?
I can I need maybe I can submit it today or tomorrow. I need to do some review.
All right, Anshul, can you coordinate with Kai on whatever hurdles he's facing so that we have a quick DevNet 5 implementation? Right.
Yeah, sure, I'll do that. And as soon as like the PR is also ready, I'll look into it.
Sounds good. All right, since we have Kamil here, so let's move to uh, DevNet for Sims with Shadow. So with regards to that, I'll just present it to Kamil to sort of take the lead on this. So Kamil, where do you think we are currently?
Yeah, I was playing with basically Shadow and Link Quick Start since yesterday. Yeah, as I wrote in the chat, I think. Yeah, basically the main question was, okay, say we want to run large-scale simulation starting from 64 nodes, how large we can scale, and the question was like how much RAM Zeam and other clients would consume, so that yeah we can estimate how large server we need for the simulations. Yeah, so from what I see, I think I wrote in the chat like Zeam consumes around 400 megabytes per node if it's not an aggregator. If it's an aggregator, then around 600 megabytes. Yeah, I managed to do simulations using Link Quick Start. I think the simulation lasted like say 6 minutes of simulated time. So yeah, I think it's based on that you can estimate how much we can, yeah, how large we need to have a server. What I observed, well, yeah, today I also managed to run Link Quick Start so that we have like Zeam working together with Clean under Shadow. So basically, yeah, so everything worked, finalization progressed. That's good. So yeah, based on that, yeah, depends on like if we want to say have like 100 nodes, so we can estimate. So like we need maybe 60 gigabytes. Yeah, if we have like 64 gigabyte server, that would be good enough, I believe, like with some margin to run maybe 100 nodes simulation. Yeah, that's already good. I mean, there are a few things that we need to. I mean, the thing that Zeam and Clean can run under Shadow, that's great. That's a good start. What we need to do next is, well, as I can see it, is yeah. For now, we're just testing. I don't know, like I didn't check carefully what exactly the underlay network we use when we simulated Shadow. Most likely, it's just simple, maybe 1 gigabit network. This is not realistic. So we can, with Shadow, we can do stuff like to have their like EIP 787 or requirements, or if we want to bump them, yeah, we can do this easily as well. That's regarding bandwidth requirements per node. Another question is latencies between nodes. There are a few options what we can do there. Yeah, I would start, maybe the simplest one is just geographical latencies between nodes. Basically, what is that? Is yeah, it's we have a data which is like simple JSON file which we use in P2P team. Basically, the latency between countries, so that inside countries the latency is very small. It could be just be even 1 millisecond, up to maybe 30 milliseconds. And between countries, yeah, it depends on like real distance. And then we have like the distribution. We know the distribution of Ethereum nodes, like in which countries we have how many nodes, and that then we use this distribution to kind of like, yeah, with certain probability assign nodes to certain countries. And then, yeah, the strategy could also work to define latencies. Another one, yeah, we have also RIPE Atlas database. It's a bit outdated because I think it's from 2018, but it also had some data for latencies between nodes, so we can sample from there as well. So yeah, anyway, that's one thing. Another thing is what we need to introduce for proper simulations is so that just for everyone to understand, if you didn't work with Shadow before, yeah, Shadow is a discrete event simulator, and it's focused on networking. When we do everything besides, so it basically it simulates a system syscalls, and the times moves forward. Well, for example, if we do, say, aggregation, like, for example, signatures aggregation, from Shadow perspective, it will look like instantaneous. I mean, it's just less than 1 millisecond. It's just 0 millisecond for the aggregation, because, yeah, it doesn't. It doesn't simulate compute the time that would be taken in reality. What we should do instead of, we should add some artificial sleeps, say before, well, some heavy operations like signatures aggregation, yes, snarks aggregation. Verification of signatures, it's usually pretty cheap, less than 1 millisecond, I believe. But yeah, anyway, that's also would be great to have. Ideally, if we could have this, I think in Clean we did this so that it's more like environment variable, and then when we build Clean with the Shadow config enabled, yeah, it's basically just sets these environment vars. It basically puts them into binary. This is not super convenient. Ideally, if we could have, like, say, either environment variable or CLI flag, so that we can dynamically change like what is our signatures aggregation rate, or what is our verification rate, snarks aggregation rate, whatever. And then, yes, that would be very convenient, so that then we can simulate real networks, so that we can say, like, for example, we want to run an experiment, like, say we have 64 nodes network, or even 100 nodes network. We say we have like that many aggregators, we have that rules for latencies, that rules for bandwidth, this is our signatures aggregation rate, and so on, so on. And then, yeah, we can play with these parameters and see how yeah, this basically progresses, well, how finalization is affected, and how attestations are propagated. Yeah, to check how attestations and blocks, for example, propagate, yeah, we need just to ensure that we have proper logs, and then we can collect these logs. Claude is very good with this. I mean, we can just, then once we have the output data, we just can ask, like, hey, what was the attestation, propagation, and so on. So yeah, that's what we can do for now. What would be great if, for example, yeah, since this is Zeam call, but it's basically for any clients that want to run simulations under Shadow, would be great to have this some flag, either CLI flag or envvars, to kind of set some artificial sleeps before aggregations and other operations which I described. Other than that, I think we're good. So we can run simulations both under ARM, because I patched Shadow so that it runs in ARM, and also in AMD. I have 64 gigs AMD server. By the way, simulations run much slower there in comparison to in ARM. So that's just also something to keep in mind. But simulations work in general. But if we have, sorry, I will stop here because maybe I speak too much. If you have any questions.
If I understand, so there is there no actual computation that is happening? What do you mean when you say sleep? Maybe we'll just go and dig into details of Shadow. I haven't done it so far. So are there actual computations happening, right?
What kind of competitions?
Like aggregation, right? Aggregation, and then
no, there is no real. Well, it's kind of real aggregation is happening, but from Shadow perspective, from simulated time perspective, it takes less. It just takes zero milliseconds. Yes, and that's not realistic, of course. But that's good from Shadow. I mean, say we have like 100 nodes, and if now I get what you mean about competition. So if we like have 100 nodes, they all need CPU resource. Then if it was like in real time, then it would not be super realistic. Here, we intercept system calls, so we it's basically can happen. So it's in fact happens sequentially. So then we have some aggregation happened by some node, but in reality, from simulated time perspective, it just takes 0 milliseconds. So it's
got it.
Fine. Yeah.
Got it. So basically, real computations are happening, but Shadow is not taking in that time because that simulated time is 0 for it.
Yeah.
Got it. So, I mean, this is just about the nodes, or if we put more validators on each of these nodes, then the computation time will obviously scale because aggregators will need to work a lot. So my question is, what is the kind of network that we should target to simulate?
It's easy to get confused here. What do you mean by nodes? Do you mean like each validator in fact can run multiple validators? They might be kind of hosted on the same node. Is that the behavior that you're interested in simulating, or what?
Yes. So, like for example, when we run lean quick start based DevNets, one node can have 4 validators or 100 or 200, right? So let's say if we want to simulate maximum number of validators load as well, even though we might not explore the number of nodes, we can say that, okay, there are 600, 200, I don't know, whatever nodes around the world, simulated around the world, and they have, let's say, 1,000 validators each. And that means that we can simulate like 60,000 validator network, which is how these things are, which is how actually Ethereum network is, because average number of validators per node could be really high.
It could be. It's a debatable like how much we need to account for this, because there are ongoing efforts in kind of consolidating validators right now, so that we have like MaxCB and so on, so that large node operators, they do not in fact run multiple validators, but they just merge them into a single logical validator. So both logical and physical. So that's we hope, and there are in future, I think in the roadmap we have goal to have like 128K validators, so that we kind of want large operators to consolidate, and also there are ongoing efforts like in batching attestations.
So basically, having these many validators will also sort of increase the network load in the subnets, right? As well as because that much attestation data is going in. So I think it is a bit relevant and can give us important insights with that regard. Okay, what is the subnet sizing that we want? So it could be worthwhile to also pump up the per node validator count in the simulations. My question is basically, what is the kind of architecture or the network that we try to simulate, and what is the target of the end results that we want from it, right? So if we basically define this before we start these experiments, now that we know that Zeam and Qlin are capable of running under Shadow, so if we define these targets, so then we can basically say that, okay, this is the kind of network we are trying to simulate, and these are the results for it.
Yeah, if you asking like what kind of network, are you asking about topologies or what, or how many validators per node we should target?
It is sort of a mixed question, right? So I mean, it is like yes, we need to break it down and figure out how to go about all of these particular configurations. In terms of topology, I think the current topology that we are following is the subnet-based topology. So then how many subnets, or what is the subnet size that we should be having, so that basically an aggregator can handle it, or what kind of aggregators do we need? Do they need to aggregate across different subnets? So, or basically another variant of the same question is, how many subnets do you think a normal typical aggregator should aggregate, and what is the redundancy of the aggregators that we want in a particular subnet, right? So these are all the questions that come up to have a production kind of network running, and that is the main aim, to collect all this data with this particular sim, so that we can say that, okay, this is the configuration that we should target for long running devnets or a public testnet.
Yeah, I mean, we can test this. We can simulate. I mean, if we have any client, maybe I missed that, but yeah, do we have like this functionality in DevNet 4 so that an aggregator could be assigned to multiple subnets? Okay.
So we have.
Yeah, then as long as we can configure that, it's not a problem. Yeah, we can test
No,
this.
but the problem is even with a single subnet, we are not able to achieve finality. That is, when one aggregator per subnet listening to attestations on the same subnet it is part of, we're still facing issues. So it's too early to probably make an aggregator listen to multiple subnets. But I believe Gajendra's question is, I mean, we ought to provide a requirement to EF in order to specify for a long-running DevNet how many machines do we need, or how many servers we can test this on. For that, we would need to use the shadow simulations to arrive at some kind of estimate of how many machines we would need, what would be the monthly budget, or something of that sort.
Right.
I mean, even before we go there, the first... Sorry, even before we go there, the first thing is, in order to run shadow simulations on a server, how big the server should be. So that's the first estimate we have to provide.
Which, if that was the question for me, I would say that 64 gigs should be good enough for now.
Okay.
Obviously, the more cores we, the RAM, the larger the RAM, the larger the simulation, the more nodes we can run, and then the more CPU we have on this server, the faster each simulation, or the less time it will take.
Okay.
So what I understand, Kamil, is that CPU is not that much of a concern, because whatever is the compute time, it does not matter with regard to Shadow, right? And you can take 2 seconds to do an aggregation, and on Shadow we can say that, okay, it was well under 0.8 second, right? Because they are all system calls based, where you intercept it and artificially move the time.
Yes, I mean, each simulation could take some long time. I mean, say we want to simulate 5. minutes of simulated time, which is like, yeah, like say 5 minutes of the network time. If you want to simulate that, in real world clock time, it would take like, it depends. Yeah, but to be honest, I didn't test that on AMD server yet, like this large simulation. On my Mac, it took like maybe 15 to 20 minutes for 64 nodes, I believe. But on AMD, it was much slower, so it might take an hour for a single simulation. But still, I mean, we can do some kind of, I don't know, launch auto research, for example, like just play around with parameters and rerun simulations constantly. Ideally, Shadow is discrete event simulator, so we can just, it has seed parameters so that we can change seed and then it's not works perfectly every time, but yeah, if our clients, they do not have any well, if they're truly deterministic, if there is no like some unclear source of randomness that Shadow cannot intercept, then yeah, all simulations, they will behave exactly the same between all runs. I mean, given the seed, given all the parameters, and if we want to reproduce, for example, yeah, we face some issue. Okay, with this seed, with this parameter, we notice that finalization stalled, and then yeah, we can reproduce that, debug, add more logs, and the behavior should be the same. So yeah, what I'm saying is, yeah, even if simulation is taking a long time, yeah, we can. I mean, we have a server, we just leave it running, maybe then create some kind of observatory so that yeah, we can see like then we just wake up in the morning and check what happened during the night, how finalization was progressing, and so on. Yeah.
So I just shared a link for you and Gajendra from Hetzner. They offer server auctions, which are older configuration servers with higher RAM, but they don't charge a one-off set-off fee in this. So if there is a configuration here that you like, we could probably place an order for it, and we use it only as long as we need it, maybe. So you have
okay.
in the chat, go in this chat, I shared it.
Yeah, if this is really for limited time, we should kind of allocate this time wisely. So maybe first create. Yeah, luckily I can. I have my own service, so yeah, just create some scripts there. What I would really love to do, what would also give us a really nice picture is, yeah, it's 2026 again. With the help of AI, we can visualize really nicely what actually going on in the network. If you saw, yeah, you've been, Gajendra, you've been in the CAN. Raul showed these demonstrations for X-ray, where it's basically we fetch data from all gossip subtopics within the slot, so we see how each slot, during each slot, like at which, at what period of time we had like the spikes in bandwidth. So this could be visualized really nicely. And also we have a thing like NetViz, which gives us really nice picture of how, for example, attestations propagate. Yeah, what I really want is, yeah, take some time and work on kind of visualizing this. It should not be too complicated, yeah, because we have already NetViz, we have X-ray, yeah, just yeah, patch some client, it could be clean, it could be Zeam, whatever, and then yeah, once we have a server, yeah, we run the simulations, yeah, like with different amount of nodes. We collect all the data, and then we can put them on some website so that, yeah, we can see actually visualization. Everyone understand like where we actually spend the bandwidth, and that also kind of gives us the picture of like, yeah, where we should improve next, what are the bottlenecks. NetViz would give us a great picture of, like, for example, we have Gossip Sub. Gossip Sub has problem with duplicates, so that, yeah, the bandwidth is not consumed wisely, so that we can receive same message multiple times. All of that stats. I would honestly, first, like, I have 48 gigs on my MacBook, so I can already like play around with 64 nodes easily. I would play with that. Then I would try to maybe vibe code all these visualizations, and then yeah, we can then deploy them on the some Hetzner or some other place. Yeah, and yeah, just keep it running, collect all the information, then yeah, upload it somewhere. Maybe O can help here because yeah, he was also he was helping with all these visualizations in the past. Yeah, that's what would I do. So what would I do now is like, yeah, it would be really great if we had this, if we introduced, for example, to Zeam all these CLI parameters. If you, in parallel, I would work on kind of running shadow simulations with maybe countries distribution so that, yeah, we assign each node to some country, and then, yeah, we, yeah, check, like, then we have more or less realistic distribution of latencies, yeah, put EIP 7870 requirements. I think you said that you have problems with finalization even in a single subnet. Do you know what was
No,
the reason?
Not with
Sorry.
single subnet. I'm saying that I mean the aggregation time when in multiple subnets is quite difficult.
Okay.
Oh,
Why it is
So
the case?
I think what Partha is saying that the aggregator, basically the aggregator computation itself needs to be optimized quite a lot, or the machine specs needs to go up to basically accommodate a multi-subnet aggregation, because Zeam as such, and I don't know, other clients might also support being an aggregator of multiple subnets. So that is what Partha was saying, that
Okay.
once you basically start being an aggregator of more than one subnet, since aggregator can't really handle it in a particular time window, then basically the network obviously gets affected because payloads are not generated.
Okay. But why are we so focused on being an aggregator in multiple subnets? I think the default assumption is that, yeah, we have like, yeah, the aggregator is assigned just to a single subnet. And if this is the case, I mean, yeah, everything should be fine, right?
So, so the benefit of an aggregator being in multiple subnets is that it can provide better payloads. So when, for example, the proposer is trying to bundle all those payloads together, it also again needs to run an aggregation because it needs to aggregate all the payloads with the same attestation data, because that is how our spec is. And if you, so if there are multiple payloads to be aggregated over time, basically you are increasing the work on the proposer. And if you are an aggregator over multiple subnets, basically you are helping the proposer create a better payload so that it does not need to do that much work later, because your number of payloads will obviously go by half. For example, let's say if you are an aggregator over two subnets. So I think we will also need to have a multiple subnet aggregators, and there could actually be a super aggregator, which is aggregating over all subnets, if we sort of start to think like how PDS is. And we can have a PDS kind of a scenario in which we say that, okay, if so much stake is attached to you, then you gotta be an aggregator, right? And if that stake is again too high, then you gotta be aggregator over this particular subnet, depending upon your node ID. So in that regard, basically we will at a node level or a network level, you can say, like PDS, we will need to have some sort of a rule which will basically enforce that there are sufficient aggregators out there in the network doing the work, so that if someone goes down, right, the block production does not stop. Block production will not stop, but basically the finalization or justification movement shouldn't stop.
Okay, we can. Yeah. So let's do maybe one step at a time. So yeah, first, I think the simpler assumption is that we have a single aggregator per subnet. I mean, one aggregator is assigned to a single subnet. Yeah, there might be multiple aggregators. We can, but anyway, yeah, we have shadow. I mean, we have, I mean, we can simulate whatever we want. First, like the default setup I would use is like, yeah, we have a single aggregator per subnet. And then, yeah, we kind of start playing with different assumptions. Anyway, everything will be in a link quick start, so it should be easy to configure. I mean, we have this validators config file, or how it's called. Like we put whatever flags and clients we want. Yeah, and then yeah, we can simulate anything. Yeah, let's just, as I said, like let's first, as a next step, yeah, introduce different underlay topologies. That yeah, I can do this. Then, if we want to have a server, yeah, maybe introduce these visualizations. I mean, let me at least spend some, maybe half a week trying to do that. If it's easy enough, then yeah, great, we can do this. If not, yeah, we just, okay, do simple simulations, well, just without nice visualizations, just yeah, collect logs and see how attestations propagated and so on. That's what I would do until maybe, yeah, and we can get back on that for that on Wednesday. Yeah, we'll see how it goes, and then yeah, we can decide like, okay, whether we ready to have like a server which we can use to start our runs. I mean, so that yeah, everything kind of goes even when we, I don't know, just some kind, as I said, like my dream is to have some kind of auto research, so that yeah, we have some AI even playing with different parameters, then create some summaries and saying like, hey, we, for example, changed the mesh size to this size, then we had this configuration when we have, for example, aggregator assigned to multiple subnets. That was the result. Yeah, on your side,
so we have,
yeah.
So we have AI integration, which looks into our lean quickstart subnets and basically tries to debug it. And probably we can also sort of direct it towards this particular thing. Like you're saying that, okay, it will analyze the results and basically suggest something on basis of that.
Ideally, yes. Yeah, I don't. This is like big picture. It's somewhere in future, but that would be great to have at some point. Now. Right. Yes. I mean, in future, I would say maybe in. Let's just have some simulations first running smoothly, so that we can configure aggregation time. We can configure latencies, all of that. When it works, yeah. I mean, yeah, then we can play with AI, start playing with AI.
Right. So on that front, basically you have Kai as a dedicated person that can assist you in this, followed up, backed up by Partha, and then by any of us, right? So basically we would like to offer our support to sort of accelerate and help you in this, so that even, you know, you are not really, you basically the load on you is also less, and most of the chunk of the work can be executed by Kai.
Yeah, great. Yeah, for now, yeah, I will just maybe keep posting sometimes, maybe in Zeam channel or in PQ Interop channel, like this is where we are. Like this is like link quick start branch, which you can take and play around, as I already did, like I think yesterday or today when I shared the branch. Yeah, I mean, I can share some recommendations. So as I said, being able to configure aggregation, signature aggregation time, start aggregation time, signature verification time, maybe. These three things, if they are in Zeam, that would be great. So yeah, and then
so Partha and Kai, could you basically please make sure that whatever configuration Kamal requires, can we do a quick PR on this?
Yes. So we basically need a sleep time. just putting artificial sleep in Zeam, just to be clear, right? So that say we have, we put a signature aggregation rate to be 1,000 signatures per second, and then our aggregator received 60 signatures. So that it means we need how much is that? 6 milliseconds or 60 milliseconds? 60 milliseconds of sleep to be put when we actually perform an aggregation in the code. That's kind of the thing.
So basically, this is the sleep we are saying to Shadow is the time that we are consuming.
Yeah, it's just a sleep. Just I don't know how it's in Zig, like in C++, std sleep for this amount of milliseconds, and then Shadow, because as I said, and then this would look like more realistic, so that like real aggregation happened. Because otherwise, okay, we do have real aggregation happening, but as I explained in Shadow, simulated time it's 0 milliseconds, and here we're adding artificial sleep, so that it's like 60 milliseconds, which is closer to what we actually expect. And because we don't know, because the parameters for this, we're constantly evolving, so we can play with different aggregation times. Yeah, that would be great. Ideally, at some point, this is not a requirement at all for now, but for some bright future, would be great if we could also play, for example, with signature sizes, with snark sizes, so that we can simulate, for example, like how the network is going when we have this less than 1 MTU per signature, or when we have the snark of size, I don't know, 70 kilobyte or so. I think last time I spoke with Emil, he said that might be even achievable at some point. Anyway, that's more complicated, because then we do not really have today this kind of snarks and this kind of signature, so they would need to be artificial as well, and this really complicates the flow. I think we do have this in clean, because we were thinking about this from day one, but it's also, it introduces, it's not easy to maintain, I would say, so don't bother with that. Anyway, that's just my thoughts. Okay, good. Okay, I think I'll work with different underlay topologies. Kai, if you can introduce these things to Zeam, so that we have these artificial sleeps when we actually perform aggregation. By default, these sleeps, they are just 0 milliseconds, so that they are not happening in production. We only need them in Shadow when we simulate Shadow simulations. So that, and then we get back for that maybe on Wednesday, and then we see how it goes regarding the next steps. Then we can decide already, like, okay, we do need a server, because we do have like a script and everything. That would be great.
Yep, sounds like a plan. Thanks, Kamil, for sort of leading this effort and helping us over there. And let's make it happen.
Yeah, good, nice.
So
Shadow channel.
Feel free to leave if you want, or you want to stay for the rest of the call. Totally up to you.
I have some other stuff that I need to prepare for. So have a good day, guys.
All right.
Yes,
Thank you.
thank you.
Thank you.
Okay, bye.
Thanks.
All right. So moving on to our aggregation and optimizations regarding that, and DevNet for runs. So Partha, what's going on over there?
Still, I've been running this multi-subnet DevNet for the past week. Every run has introduced a new issue that we have been looking into or addressing. Initially, after yesterday's run, I thought Zeam's aggregation performance was much better than the others, but we later on discovered that it was not actually so, because we were missing quite a few aggregation slots. So there was an improvement that I applied yesterday, and then Anshul has a new PR today, which would probably parallelize the aggregation. We should keep an eye on that and see. I mean, this is across the board, not just with Zeam. Everybody else is having the same issues. So unless we stabilize and achieve that aggregation within the given time slot, uh, I don't think we'd be achieving finality or justification on a multi-subnet DevNet. So that should be our priority before we proceed to, I mean,
This
scale even further or introduce DevNet 5.
this makes sense, but why did we not catch this earlier?
Uh, I mean, for various reasons. First, the issue is in the spec itself. The spec did not mandate the need for, I mean, aggregating, and probably we were missing some tests which we could probably add in the test suite. This is something I've asked Toma as well. We need better aggregation specific tests in the test suite, and Hive testing should also catch this, because everything looks good probably in a subnet devnet. We nobody paid much attention to aggregations at that time, but it starts to show that it's a problem when we start scaling up. So
what is
I
the
don't have a
problem?
correct
Can you
answer.
describe in TLDR what the problem is and what you are trying
So
to solve?
the problem is that our slot interval for aggregation is 0.8 seconds. So an aggregator has to finish its aggregation and also finish the transmission of that aggregate within that 0.8 second interval. But the problem here is that Zeam takes probably on an average 3 seconds to complete the aggregation itself. One of the reasons was that we were doing recursive aggregation, even though there was just one attestation available, which shouldn't have happened. This was a bug in the spec itself. The second, I believe, which Anshul has discovered, is that we were not parallelizing the aggregation. We were doing one aggregate at a time, which was resulting in the delay. Once PR 915 is merged, we may have more, I mean, we'll know how it's actually working. But this is a couple of things. I initially thought maybe Zeam was overloaded while processing the gossip, but the current metrics show that there is no issue with the gossip. It has received the attestations on time. It's just the aggregation process itself is taking longer. So that is something we'd have to do.
I have just
And
one
what
doubt here. So you were saying that we perform well when there's a single subnet. So
Yeah.
if aggregation is the bottleneck, then how are we able to aggregate in a single subnet? Because single subnet there are more children to aggregate and more gossip signatures to aggregate. So ideally we should work better with multiple subnets.
No,
so I think
I'll
what
tell you why,
would be
because
happening is that
sorry, go.
on single subnet, the loss percentage would be same, but spread over multiple subnets means that there is a greater loss or something like that would be happening, so that you are not crossing the two-third threshold anymore.
Yeah, and the
Assumption.
fork choice tree is completely different in a multi-subnet. Each subnet has its own view of the chain. So when you the fork choice tree in a single or a double subnet devnet was not as disjoint or spread across as you would see right now. So, for example, you see Zeam has multiple weightage for a couple of branches, but none for the remaining. ETH Lambda has a similar view of its own chain. So each thinks its own chain is the correct chain and misses on the others.
Okay, so it gets to a point where aggregators have like multiple attestation data because of the split in the fork choice, and that is, yeah, makes
Correct.
sense.
I mean, there should not be split in the fork choice. If there is split in the fork choice, that means that even the proposers are not building on the same heads, right?
So there is difference in the heads as well. So if you notice Zeam 4 and Zeam 8, the aggregators that Zeam were part of were on different heads completely. Zeam was on 600, or Zeam 4 was on 600. Zeam 8 was on 512. ETH Lambda was on 612 or something, and Ream was on 300 or something. So there was no uniform head across all of these chains. So something else is happening as well, which I've not been able to isolate
So
yet.
in the new metrics that I added were covering the subnet aggregation,
Yeah,
subnet level coverage. So that should basically show you whether you are getting the aggregates from other subnets or not.
right.
So
So
what is that data reflecting?
that was merged only last night. I've not released DevNet for image yet. I'll do that later today after this call, and then provide you with an update.
That was merged quite not last night. I mean,
But the estimate, the one that you said, right? You asked me to pick up.
No, so we already had those metrics.
so that were merged on May 18th. Log attestation subnet coverage in chain status, and then you did
Okay, I'm
another PR
back that.
of it, which was about the gossip attestation coverage. So my PR was about aggregate subnet coverage, and you also did a separate PR where you added a metric about gossip coverage. So basically both of these things should give you a good idea of what aggregates as such you as a node are seeing, and even the aggregator is seeing before it starts aggregating, right? So
Yeah.
so the metrics should basically tell you what the issue is, in my opinion,
Okay,
or which
I haven't tracked that
particular
yet. I'll do that. Yeah.
which particular subnet you are not actually seeing. So what the problem you are seeing is that you are not seeing attestations from something,
Correct.
right? Some particular subnet seems like that is a problem, and it basically becomes more in multiple subnets because then there are more fractured subsets that you are not seeing consistent data from, and that could be the problem. So not only us but other clients also need to add these metrics so that we can also see what aggregates other clients are seeing, or what is the data that they are seeing that they are trying to aggregate.
So I think like the reason for this fracture can be that we aren't able to propose the block itself in time because of the compaction process that happens. And I think I suggested it on Wednesday as well. I think we should lower down the max attestation data to something like 4 or 8. I think
But
4 is
but that is not the problem of max attestation data, right? Your same attestation data can, for example, have many payloads for that. Basically totally depends upon number of subnets you have. So if you have 4 subnets, then even if everybody agrees, then you will have 4 payloads to aggregate even for one attestation sub data for the proposer.
Yeah, but in a block, when I try to build a block, I won't have to do the compaction process for 16 different attestation data. So I'll have like
So so what should happen is that there should be a boundary beyond which you should stop bundling for other attestation data. You basically say that, okay, if you're greedily packing, then, and if your time boundary hits for a particular deadline, then you should basically pack it and move on, right? This is what you should do.
uh, yeah, that can be done, but that is not how it is being done right now. Right now, like the
So
block is proposed and then the compaction is a different process, and it will either do like a complete compaction or not. And if like there are certain attestation data that cannot have like a complete compaction that can happen, so in that case we'll have to move few of the attestation data back to the latest payload, latest aggregated payload map, because after block building,
you don't move to the latest aggregated payload map. I mean,
I think that
you already have the latest known, right? So you just propose the block base on basis of whatever you have, and basically it's up to the next proposer to fill in the gap, because then all slots will vote again, right? All validators will vote again on the slots. You don't have to remove anything back. You basically stop your process as soon as you hit a deadline, and then basically you run your proposal with it. Otherwise, you all anyway know that your proposal is going to fail.
Yeah. Okay. Yeah. Okay, I think we can add this into the spec. I was also thinking in that direction that if we should stop building the block, and for the number of max attestation data that we have already compacted, we should just publish the block with them. I think that is what you mean by this. So I'll add this in the spec itself.
Yes, correctly. Basically, have a deadline and then run with it. I'm not sure this needs to be upstream to spec because these are client level optimizations, and this is how this is how a production client differs from a spec. So basically, making spec more complicated about this might not be a good idea. So this is just a client level optimization that we need to do.
Okay.
Unless you feel that we should upstream to spec, then that is also fine. I'm not against that. Just that my idea is that spec should be kept simple, but maybe you can discuss it with Toma. If you think that this is something that should be done by all of the clients, which I guess also makes sense, then basically you can even upstream to spec as well, if all the clients are seeing these problems. But with respect to our aggregation, why is ETH Lambda doing better than us still?
No, yeah, it's almost the same performance. I mean, but they see a lot lesser errors or skipped aggregations than us, which I believe might get resolved after the two PRs are merged. Anshul's parallelization PR and ours.
And the parallels, so are we constructing some sort of a tree to recursively aggregate in the parallelization PRs, or what
No,
is the kind of fan out we are dealing with this over there?
So right now, so the PR that I just created, it basically, so what we were doing up till now was we were basically creating a new IO thread uh, when it was chance to aggregate, and I think like that was like the wrong way to do it, because we were creating a single IO thread and we were basically we had a concurrency limit there of 1. So it was basically serial aggregation. I removed it and I have added like the thread pool aggregation, how I did it in the compact attestations process. So like there were multiple issues. One was that it was serially trying to serially aggregate, and that was leading to the high number of in-flight matrix that Path had added, and the number there was really high. Apart from that, like I think it doesn't make sense to spin up like a standard IO thread out of attestation when in like the attestation aggregation process, because it is a CPU bound task. It is not an IO bound task. So not sure, but I think like it doesn't make sense to have like a IO specific thread, because it basically specializes in doing like the concurrent work, but it is not a concurrent heavy
So
thing.
my question is, are you able to engage all the CPUs?
Yeah, so that is something that I want access to, so that I can basically do like a perf analysis and see how many cores are being utilized and what is like the percentage of cores that are being utilized. So I have asked Partha to give me access to the DevNet setup that he runs, so that I can basically monitor the do like use perf tool to basically see how much percentage of the core is being occupied, and basically then optimize it on our.
So reason to have more IO threads than what we think is the best optimal is that we leave it to operating system to manage scheduling between them, right? So in that sense, it does not hurt. I mean, don't try to over optimize in terms of less number of threads that we want to keep. Basically, just say that, okay, if we have X CPUs, then we will have X threads doing the compute, even if each of the compute is sort of CPU parallelized or multi-core compute, right? Because we don't know what actually how the underlying library, how efficient is it is on multi CPU, multi-core compute. So those are all the things. So don't basically, try to over optimize and try to restrict yourself with regard to the threading. Just have trust that operating system will do the right thing.
Got it.
Also, like there's another
And,
thing where
and
we are.
on the aggregation topology, what is the best aggregation topology? Are you forming a tree to aggregate, or so what is the aggregation topology that you are following? And the second thing is, does aggregation topology even matter, right? Or you basically say that, okay, I am just taking out uh, five aggregates and building a tree with it, or I have a target aggregate in which each time I have 5 new payloads I aggregate into it. So what is the topology that you are following for the aggregation, and what is the best topology to go for over there?
So there's no topology as such because there's no max. We do like a greedy selection of children, and based on that, we do like in a single run, the API itself provides us with an option that in a single run we can do like the complete aggregation. So there's just the greedy selection that happens, and post that we do the aggregation.
Okay, so basically you are leaving it to the underlying library
Yeah.
to construct a tree or whatever they want, right? That is
Yeah.
fine, and it's also a good approach. So because it is their job to optimize this sort of aggregation structure if they benefit out of it.
Yeah, so I already had this discussion with Email earlier about optimizing it in a tree-based format, but I don't know how he implemented it eventually. So
Right. So I mean, just even forgetting about that, my question is then why do we need multiple threads slash multiple processes of aggregation running over there? Because are there
because
so many attestation datas?
uh, there
How many
can
attestation datas are there, and in is that available in some sort of a metric as well?
So, as far as I know, the lean multisig library by itself parallelizes the aggregation. So, there is no
Yeah, I'm not
specific
saying that.
metric.
I'm not saying that. I'm
yeah,
saying
so
that.
there are definitely multiple attestation data because that's why we have that in-flight metric which shows a huge
Yeah,
number. Had there been like just one, then in that case we won't have seen such a large number of uh, in-flight attestations, which have basically led to
So,
uh,
so the highest priority should be given to attestation data that match locally with your local view, right? So you should basically schedule that first and publish that first. In fact, don't even wait for everything to basically compact and publish, right? So don't wait for other aggregations to happen. So if something is matching with your local view, that is best attestation data for you, right? You should aggregate that first and publish that first, given that has enough support. Or you basically pick other things. And if you have CPU cores left, cores basically, then you could, assuming that each of these computation is already multi-threaded, then I think it is better that it be a serial process, because then you would want to give your full CPU power to the best attestation data that you think. So you have a sequence in which you can order your attestation data and say that, okay, I will process this, send this out. Then I'll process this and send it out. So instead of waiting for everything to get completed, I think this kind of priority processing as well as transmission is required. So uh, what the best thing is, again, whatever UPR that you have made, basically provide a CLI param to adjust that parallelization factor, right? And if we put it on 1, that basically means that it will process the in basically in a particular order, based on the priority that the local node evaluates, that this looks like the best destination data, so I will compact it first and then I'll transmit it. And if, for example, there is concurrency factor is 2, then basically it will take first 2 and process them, and but it will not wait for both of the two to get completed to publish. Whichever gets done, you just publish it right away.
Okay.
So let's do this follow PR. I mean, and still keep your parallelization work in 191 or whatever that is. So I'll also take a cursory look at it. Partha, you can take a deeper look at it.
Yeah.
Anything else we can do? So do we also have some time difference where you see the attestations spread out over time? Because then you can probably start early, right? You can, instead of waiting to start the compaction on the new interval, you can probably start compaction as soon as you start seeing 2 or 3 or whatever variable we have defined, Partha, for compaction to start. So this is another thing that we can start doing.
All right. One other thing I noticed in our logs where it says the head slot, the current slot, and behind. What does that behind imply? Does that mean our uh, client is as such slow or processing late?
Instead of behind, rename it to missed. You could have missed b- because there was no proposal, or you could have missed because you are behind, actually. So
Okay.
there is no way to know unless you are inspecting the client and you know that, okay, you are not behind, you didn't get any. I
Okay.
guess
Because in
you
few
can say that
cases,
if there is nothing in
uh,
the queue, then you are not behind, you have missed it.
right. Okay. Because I on occasionally I've seen that Zeam when it's running as an aggregator is behind 24 slots, and then it suddenly catches up to 0. So I wasn't quite sure
So
how that could happen.
that means that either that particular Zeam node or some other Zeam node produced a new block that's whose parent was 24 slots behind. That is the easiest way I can explain why
Okay.
this could happen. Or your Zeam node did not see 24 slots in between and then somebody proposed, right?
Right.
So instead of behind, I guess you can say missed. And now missed
Okay.
might actually mean missed or orphaned or whatever, right? Whatever you want to call that terminology. But yes,
Okay.
behind might give a negative connotation in the sense that the node is slower even when there is missed proposals or something else has happened in the network. For example, a block was not correct,
Right.
so you rejected it. So let's change behind to missed, I guess.
Okay.
So anything else we have on the plate? Kai, you have any ideas of improving the aggregator performance?
Um, no, I just know that aggregation already parallel in the Rust side, so I'm not sure. So I think you said your idea maybe good. So um, currently I have no other ideas. for that.
Got it. Just everybody keep in mind how we can, just apply your brain cycles on it, how we can further improve it, throw ideas. No idea is a bad idea. We might get a good idea out of it. So just keep thinking on it and let's make the aggregation bottleneck, let's solve it.
There's another thing that I was looking into, and probably I'll raise a PR. It is not related to aggregation, but right now in network and networking layer and the DB layer, we don't use the async IO syntax that was recently reintroduced back in 0.16. So I'll reintroduce back and we'll have some concurrency there.
Yep, sounds good. And I think it will also sort of make code cleaner. So that is anyway a win over longer time frame.
So, but I think it's in 0.16, the async IO is not ready in the. So right now there currently there is only multi-thread IO.
Okay, I'll look into that as well. I don't exactly understand.
Yeah, so the event IO is not ready in this version. So. But I
So
found another library which name CIO. So I think we can use it. So and also we can and also I think we can use it to instead of the lib xev because the lib xev is not comparable with the 0.16 upgrade mentioned in his latest latest PRs, I think. So I think the ZIO library maybe is the best options to use.
yeah, so until it makes sense to look into what Kai is suggesting regarding the new library, and yeah, I think libxcv was a hack. So let's move to something better. Nupur, do you have anything for us?
Um, I'm just posting the rolling actions from the team meetings, so you can take a look. Other than that, not really. I'll work on the CI this weekend for the shadow, and that's it. So
All
this rolling
right.
actions was created by Zclaw, and it has all the like the Zeam groups chats and the Zeam meeting transcripts. So it has accumulated all three places and then created this rolling actions.
So can we also sort of do an automated posting of this after every call, in the sense that it automatically gets posted in the group?
Okay. Okay.
See if we can do
So
that.
for that, I need like the for the transcript posting that you asked, that transcript automation, that it should be public. So for that, I would need to coordinate with you because by default the Zoom the Google Meet recordings are not public and they cannot be made public. So we'll have to
Okay.
transfer them. I'll have to write a script on in Google Script, so that which will transfer the transcript to a public folder.
Or you can have some sort of a integration where basically, you know, it does auto transcription and joins in the call, right? So there are tools like that.
Okay. Yes.
If those tools are handier than this particular thing.
Okay.
Can we have this on a separate channel, because it can we may lose if we want to refer to the transcript or actions maybe.
Yeah, we can create some sort of a separate channel on it. Topic. Do you mean topic or channel?
Yeah, topic. Sorry, I'm talking in Slack terminology. Yeah, I was referring to
Right.
a separate topic. On.
Okay. Okay. I'll do that.
All right. We are over time, and unless
So,
anyone is. Yeah.
Sorry, Gajendra, before we go, just wanted to check. So we wait until Kamil comes back before we place an official request for a machine, right? For Shadow. He
Yes,
appears to be.
but we start looking into the sleep configuration that he wants us to do, right? So
Yeah, that we'll do. I'm talking about the actual budgeting of the server and other requirements.
yes,
We wait until it
let's
comes up.
wait for him to come back because he has a 48 GB machine. So
Okay,
why not?
but your idea for the end of the year was how many nodes, or rather, how many validators you want to test in the plan? What do you think
I
can
don't
be?
know. We'll figure it out later.
No, that's
is
fine.
a-
I'm just trying to understand what would be a convincing number for us to probably convince the rest of the core devs to look into this seriously.
I mean, how many validators do we have on Hoodie? That
I don't know. Oh, okay. To match that.
yeah, I guess if we match those, not not the validators that external people are running, but the Hoodie validators that ETH Panda Ops is running, I guess, or we might not even match that. We might even go a bit lower from it because our computation requirements are higher because of the new
Right.
crypto, and
Mhm.
so in that regard, I mean, we'll see basically, but yes, some sort of a fraction of that, not a small fraction,
Okay.
but some reasonable fraction of that could work.
Okay. Sounds good.
All right, guys, thank you for being in this call, and see you on Wednesday in the PQ interrupt call 26th or 27th, and then on 29th for the normal Zeam call.
Yep.
Thank
Thanks.
you.
Speak to you.
Thank
Bye.
you. Bye.
Thank you.
Bye.
Bye.